Hello and welcome back to the Farmyard Academy. So we're here with another video today and we're looking at proton NMR and we're looking at how to attempt these questions, trying to give you an easy strategy that will help you. If you've not watched the first video, I definitely suggest watching that because that sets the scene. Pause the video now, have a go at the question from the information that I've given you, see how you get on, and then we'll make a start. Okay, so what we're going to do first is we're going to go straight in stage one, which is to look at the information given in the question. Now there can be lots of information provided in questions from previous questions about the chemical reactivity. You can have IR information, mass spec information, etc. Now in this information that's been provided here, it's a little bit shorthand, but it's, you'd still get similar information in an exam, but you'd be a few more words really. But as you can see, if I highlight, all they've given us is the top part here, which is the molecular formula. So we've got the molecular formula given, which comes from mass spec data. Just as AS recap, molecular formula is the actual number of atoms, so we know that we've got 4 carbons, 10 hydrogens and 1 oxygen, and that's it. That's all the information been provided in stage 1. Stage 2, we're going to look at the chemical shift, and that's where we find these peaks from 0 to 12. If you look here, we've got 0 to 5, and this is the aliphatic region. Now, aliphatic is these small molecules, and its functional groups such as alcohols, alkenes, you can have ethers, esters, you can have ketones. There's quite a few, haloalkanes, etc., and alkanes, etc. What we don't have is any aromatic substances, because that would be group 7. Sorry, that would be chemical shift 7. And if it was 12 to 10, that's aldehydes and carboxylic acids, so those protons. So we can rule those out straight away. So we'll just cross those off because we know we haven't got any of those. So we're just dealing with 0 to 5. This peak here, we can ignore that as well. So I'm going to cross that off, because that is TMS, so that's your internal standard. And again, you can find out a bit more about that, what it stands for, in the first video. Okay, so moving on then to stage 3. This is where we're going to look at integration. And that's usually given in a table. Sometimes it can be on peaks as well. You can get flicks that look a bit like this, and they can have values on top of those peaks as well, but they're just integration values. This tells us, it comes from the area of the peak, and this just tells us the actual number of hydrogens within that area. So here it's a 2 to 3 to 2 to 3 ratio. Now we can tell that they are the actual number of hydrogen, so actually it's a 2 hydrogen, it's a 3 hydrogen, it's a 2 hydrogen, and it's a 3 hydrogen ratio. And the reason we can tell that is because if we go back to the molecular formula, if we add 2, 3, 2 and 3 together, that makes 10, so it's the actual number of hydrogens. If it was a ratio, it could be a 1 to 1.5 to 1 to 1.5, and then you just have to make it a whole number ratio to get the actual number of hydrogens. That's really helpful, because what that does, it starts making us think that this group is potentially a CH2 group, this one is a CH3, this one's a CH2, and this one's a CH3. I say potentially because in rare cases this could be a 2 times a CH group. That's rare though. Most of the time you're dealing with a CH2, CH3, CH2, CH3. If these ratios change and it becomes a 6 hydrogen group or a 9 hydrogen, it's potential that you're dealing with 2 methyl groups. But that's just something to be aware of. Okay, so moving on then. So we've got the next stage, which is to look at the stage 4, which is to look at the spin-spin coupling. So we've got spin-spin, or sometimes it's known as multiplicity, so you can call it whatever you want. And then that's where we're going to look at these groups and to see what they're next to. Okay, so I'm going to write down here, I'm going to put an arrow down here, and I'm going to highlight this bit so you can see next to. Okay, I'm going to highlight that. So this CH2 group, because it's a triplet, and your N+1 rule must be next to a CH2 group. So I'll say that again. This CH2 group, because it's a triplet, again I'll highlight that in green for you up here, it must be next to two other hydrogens, because 3 minus 1 makes 2, so it's next to a CH2 group. Then we move on to this peak. I'll highlight it in yellow, which if we look at is a singlet. So that tells me that this CH3 group is next to nothing. So I'm just going to write on own. So it's on its own. Okay, because it's not got any hydrogens next to it, they won't interfere with one another, and it's not next to anything. So we know that that methyl group is on its own. Then we move on to this one, which looks a little bit complicated. We'll highlight that in pink. It's got a spin-spin pattern of 6, which means that this CH2 group has to be next to 5 hydrogens. Okay, so we'll think about that. Makes it a bit tricky, and we'll come back to it in a second, see if we can figure it out. And then the final one, we'll highlight this in blue, is another triplet, which is telling me that these CH3 groups are next to, again, N+1, so minus 1 off that triplet makes 2, which means this CH3 group is next to a CH2. Okay, so then what we've got to do is bring all that information together to stage 5 to make the puzzle pieces of our structure. And we're going to start with the easy one. We're going to start with the one that's on its own, which is a methyl group. So we know we must have, that must be our first puzzle piece, which is a CH3 group. Okay, so that one's gone. Then what we're going to do is we're going to go back to the first one, and we're going to say the CH2 group, if I underline it here, so this CH2 group that we figured from the integration is next to another CH2 group. So we're going to start with our other puzzle up here, and we're going to say CH2 is next to a CH2 group, and that will be our next puzzle. But it gets a little bit tricky, because we've also said that we've got a CH3 group that is next to a CH2 group. And we've also got a CH2 group that's next to 5. So what are we going to do with this CH3 group here? Well, we're going to put it there, because now that fits the pattern. We've got a CH2 group that's next to a CH2 group. We've got a CH2 group that is next to 2 hydrogens here, 3 hydrogens there, which makes 5. So that CH2 group is next to 5 hydrogens. And this CH3 group is next to a CH2 group. So there is our next puzzle piece, and that's not easy. That's quite tricky to do, but we've got there by using a bit of problem solving. And again, if you're showing you're working out like this, you're going to get marks for this working out. So sometimes it's not always about getting the overall answer. It's about demonstrating that you can problem solve and you can figure things out. But that's quite tricky. But that's what we're left with. And then we're not finished yet, because those are our 2 puzzle pieces. But if we look, we're missing something. We can't just bring these 2 substances together, because it wouldn't make this spin-spin pattern in the chemical shift. So we must be missing something. So we go back to our molecular formula and we see if we've missed something out. We count up our carbons, which makes 4, and we take off those. So that would be the carbons have gone. We add up our hydrogens, and that makes 10, and that would make, if we take 10 hydrogens away from 10, that gets rid of all those hydrogens. But we're not accounting for our oxygen atom. So one of our puzzle pieces has to be our oxygen atom, like that. And then it's just a case of bringing these substances together that fits the pattern. And there's only really one way we can do it. Our CH3 group, because it's a singlet, is on its own, so that must be attached to an oxygen atom. And then our other piece of our puzzle comes in, and we're left with our CH2, CH3 in there, like so. Okay, and that's our final answer. And that's how you do it. So hopefully that's helped. Keep it to the 4 stages. Stage 1 is the info. Stage 2 is the chemical shift. Stage 3 is your integration ratio. Stage 4 is your spin-spin multiplicity, spin-spin coupling. And stage 5 is to make your puzzle pieces. So have a go, see how you get on, and hopefully that's helped. Okay, see you on the next one.